so you wanted to look at the third one? Okay. I'm not going to get super picky here. I know that if you plug in 0 and 1 and -1, you'll get those 3 points here. I'm going to get real generic here just for argument's sake so I can continue with this. Okay, so here's the basic shape that we're looking at for a cubic function. How about that domain? Smash it all down on the x-axis, and what do you get? You get the whole number line, don't you? Okay, how about if you crush it all onto the y-axis? What do you get for range? It's the same thing, right? Increasing, right? Left to right as you go through the graph. Roller coaster. Okay, isn't the entire thing increasing? There is no decreasing portion of this graph. Remember, you're going from left to right through the whole thing. If I didn't like y equals x as a roller coaster, do you think I'm going to like this one better? It's going up faster. How about extrema? Let's relative mins and maxes. Do you see any relative mins and maxes? No relative mins and maxes. Are you going to get an absolute min and a max if you don't even have any relative mins and maxes? No. I always say find the relative mins and maxes first, then choose out of those to get your absolutes. I'm going to abbreviate on number 5. Not. Okay? Goes along with what you like to say over here. I know you probably didn't even put the T on, did you? You just went, no. Okay. Discontinuities? None. I believe I was instructed to say, on my mama. Is that what I'm supposed to say after that?
On your honor.
I thought they said it was supposed to be on my mama. Like you were swearing like on their grave or something like that, on their life.
Why?
I don't know. They just told me to say this in one of my earlier classes today. They said I should work that into my notes. So I already know that no cap means you don't capitalize things, you know, but end behavior. In behavior, you're looking for limits. What's the limit as x goes to positive infinity of the graph? D and E, that's right. Or you could say it's going to infinity, which it is. How about the limit as x goes to negative infinity of f of x? Okay, you could either say negative infinity or does not exist. That's true.
Don't you have to make one?
Okay, when do we have to make a third one, folks? When we are looking for discontinuities. If you can find a discontinuity, which this one doesn't have, but if you can find a point of discontinuity, then you have to have a left limit and a right limit and an overall limit. But that's not the same thing as end behavior. Okay? Now,
So where would you put that?
it would be under the discontinuity category if you had any discontinuities where you would have the 3 limits. Okay? Now, let me ask you a question. Don't write this down. Just look. Let's see here. How hysterical is that? Can you read what that says? The limit as x approaches infinity from the... No, from the right. Approaching infinity from the right? Are you kidding me? Who does this? Nobody can. So you'll never see those kind of little pluses and minuses. Okay? The only way you can approach infinity is to go from the left, correct? There ain't no way you can do it any other way. You just keep going higher and higher and higher, farther to the right. So we don't put any pluses and minuses on infinity, okay? That's when people lose their jobs. Okay, now, how about asymptotes? There weren't any asymptotes. There are no lines that you get closer and closer to but never touch. Okay, so there were none. Symmetry of the graph, so step number 1, right? Opposite of f of x. The opposite of f of x would have been negative x cubed, right? And so step 2, what happens when you plug in negative x to the original function? So you take negative x, you raise it to the third power, right? And negative x times negative x times negative x. How many of the negatives cancel out? 2 of them do, right? So that leaves me with negative 1 times x cubed. Did we get the original y value? No, so it's not even. Did we get the opposite? Yes, so that's odd. Very odd. Any zeros on the function? Sure, it crosses through at x equals 0. So that's the analysis of the cubic function. You need to be able to do that for the other ones. And sounds like fill this out. Some people have even asked if they could come after school and get some help. Yes. Before school too. I put it up on the chalkboard or the resource room. Or please take advantage of getting help. Yes. Can we be more specific? Because I need to move on and do more stuff. I mean, because we did a little bit. Is there something in here that you're like, okay, I didn't get that?
I don't know. Like, okay, can you just do like
Okay, so we know that we've got a discontinuity at x equals 0. We can see that in the graph. You guys told me that it was infinite yesterday. All right, now, which is completely true. So what is the limit as you approach 0 from the left? From the left. So you're coming at the graph this way, approaching the x value of 0. And what y value are you getting close to? Okay, if you think you're getting close to 0, then I think, so you're saying we're getting closer and closer and closer to that point right there? I mean, what's going on here? As we get closer to the x value 0, what's going on with our little roller coaster here? You're going down. Okay. Anyway, so that is going towards negative infinity, right? That's a does not exist. Either of those would work for me. What's going on as you approach 0 from the right? Right? We're going to positive infinity, aren't we? What's the overall limit? There is none. That's what happens at every single infinite discontinuity. Something like that is going on. That help? And that's where we get the three limits. Because you got the left, you got the right, and then the overall. Okay? But not at your end behavior. Okay. I need to move forward. You got the notes page in front of you. Hopefully you understand that those are pieces. And does it pass the vertical line test, yes or no? Yes, therefore it's a function.
Wow.
Wow. Pieces of graphs and it's a function. So it's called a piecewise function. All right, now, I need to show you how to write the equations. Okay, first of all, we'll start off with a little f of x and a bracket or brace, whichever you want to call it. I think that was yours. Let's focus our attention on this part right here. What's the equation of that line? Does anybody know the slope of that line? Can you count the slope? It's a 2, right? So it's a 2x minus what? All right, now, for those of you wondering, how do we find the y-intercept? Just kind of envision in your mind coming back using the slope. Where would it hit the y-axis? -6. All right, so 2x minus 6. Now, I should have given myself a little bit more room here, so I'm going to have to rewrite this a little smaller on my page here. 2x minus 6, comma, if x is greater than 1. Now, why didn't I put greater than or equal to? Why didn't I put an equal to on it, Mr. Prisbaki? There's a hole at the graph, right? At the end of that, there's a hole. It's an open circle. It's not a closed circle. I bet when you were in middle school and you had to graph things like x is greater than 1, you did an open circle and you did an arrow to the right. Guess what? The difference in this question is that now it's not a horizontal line. It's got a slope other than 0. So that part of the line is 2x minus 6 as long as x is greater than 1. Well, what about the other part? This other part down here. What's the slope of that? What is it? Up 1 over 1, up 1 over 1, up 1 over 1. Sounds like 1. So we've got 1x and what do you think that y-intercept is? 0. If x is less than what? -3. If x is less than -3. We can see that it starts at -3 right there, and it's an open circle and it goes to the left. Folks, that's how we wrote a piecewise function. 2 parts with conditions on x. With conditions on x. All right. Hopefully you were able to write that down as we went through that.
You put a bracket on the other side?
No, don't need to. All I'm doing is showing that there's 2 parts, that f of x has more than 1 part. It's not just a simple, nice, easy, straightforward. There's different pieces. But no, you wouldn't need another bracket. If you wanted to, and it would make you feel more comfortable, okay. It's not going to hurt anything. Not going to bother me. Ooh, what's the limit as x approaches 1 from the right? What's the limit as x approaches 1 from the right? What is the limit as x approaches 1 from the right? Come on, folks, figure this out. As x approaches 1 from the right. What? What's it getting close to? I mean, I'm kind of looking at this, and as we're getting closer and closer and closer and closer and closer, it looks like we're getting closer and closer to a different number, and it ain't 0. Hey, -4. We are getting close to -4. Look at that.
And this is for the asymptotes.
Nope, this has nothing to do with asymptotes. There are no asymptotes to this particular function.
But didn't you just say that?
We talked about end behavior.
Discontinuity.
Yeah, discontinuities. Okay. I'm just asking some random questions to see if you can figure out what these limits are. How about the limit as x approaches -3 from the left? -3 from the left. As we're coming up, it looks like we're getting closer and closer to -3. Yep. The y value looks like it's getting closer and closer to -3. All right, just thought I'd toss some questions at you, see. All right, we need to graph these things. Now, if you are struggling with these graphs, you have a handy-dandy piece of equipment here that you can use called a graphing calculator. Now, it would hurt my feelings a little bit if you were doing it with this graph, but you know, just for kicks and giggles, we'll do it. We'll graph this thing. We'll use our, oops, better plug in the camera, otherwise it don't work. Just be smarter than the technology. All right. No, I don't need a natural log. Okay. I'm hoping everybody in the room knows how to graph x plus 5 and y equals -4, but suppose we didn't. We could look at the graph. All right, now, when you hit the trace button, you can see that mine is blinking on y equals x plus 5. If I want to switch to the other line, I just hit the up or down arrow, and it shifts back and forth between the two. So if I want to know about points that are on y equals x plus 5, I'll stay on that line. And I can type something like, let's say I wanted to type -2 and hit the enter button. It tells me that if I plug in -2, I get 3 for y. Okay. Now, is x less than -2? That's this one right here. Is that an open circle or a closed circle? Open. Which way do I draw the arrow? Left or right? Smaller. That'd be left. How about the other one? Is it open circle or closed circle? Closed. Which way do I draw the arrow? Left or right? To the right. Okay. According to the picture on my graph, I had a -2 and a 3. Negative 2, 3. That would be an open circle. You just told me it would be an open circle. What happens if you plug in? Now, according to this, I need to pick something smaller than negative 2. Please pick something smaller than negative 2 and tell me what it is. Negative 3. Thank you very much for not saying negative 1. Whew, man. Lots of people saying negative 1 today. I'm thinking, whoa, that's bigger. All right, so negative 3. So if I type negative 3 on my calculator, now I know and you know negative 3 plus 5 is 2. And negative 3 comma 2 is right about here. So the graph of this is doing that. So y equals negative 4. Well, at negative 2, guess what you get? Negative 4. Guess what you get at something bigger than that? Negative 1. You also get negative 4. How about at 0? Negative 4. How about 1? Negative 4. Yes, we know it's a horizontal line. So coordinates, your graphing calculator does not do a great, fantastic job of drawing piecewise functions on its own. You actually have to show what you're getting rid of. Okay, let's see if we can answer these questions. What's the limit as x approaches negative 2? From the left. From the left. We can trace it or we can just draw it, whichever. I don't really care. So I'm guessing he's suggesting 3. That's true. That is true. You are getting closer and closer to that open circle, which has a 3 for the y value. How about negative 2 from the right? From the right side, you'd be on the red part of the graph. That would be getting closer and closer to negative 4. So you have about 20 seconds to think and talk to the people around you and figure out what you think the answer to the last one is. That's crazy. See, that was tough. Here, just keep getting higher. There, doesn't even make a difference. Nothing out there. Increasing, decreasing, you're all sleeping left or right. This was a roller coaster. What part right? Looks like I'm going down. And if I was here, I would be down. So this entire money. There's a bottom point with no here. There's no light. Anytime you have a fill, that's what you all discuss. And the lowest of all of them is the highest of all of those. So truthfully, just look at the actual same as a fill. And there aren't any of those. So I really hope I will. If you spend some time around the class, I'll pick up with more. Okay, what's the decision? Negative what? I didn't hear. I didn't hear what you said. -2?
Maybe.
No.
Yeah,
Ah.
so-
I'm gonna strike that one from the record. Not -2. What is the limit as x approaches -2? I got to vote for D and E. I got a -1. What was that whole discussion that we had about overall limits? They have to be the same, right? The left limit and the right limit have to be equal. If they're not equal, we don't have an overall limit. Okay?
We'll see Monday.
Okay? So if you need to use your y equals 2x plus 1 and your x minus 2 quantity squared, right? You get those entered in your calculator if you feel the need. You can graph them. Obviously one's a line, one's a parabola. The trace button, and then if you want to use the feature of typing in numbers to kind of help give you some idea of what's going on, that's a wise move on your part. So this would be an open circle headed which direction? Less than 1 would be left. Closed circle which way? Right. Okay. Now, what happens when I plug in a 1 in the first equation? What is 2 times 1 plus 1? Sounds like a 3, right? Which if you use the trace button on your calculator, I'm sure you got 1, 3, and you'd put your open circle there. What's the slope of that line? Isn't that a positive 2? So down 2, 1 to the left, down 2, 1 to the left, down 2, 1 to the left. Some of you are going to ask me, well, how did you know it went to the left? Well, you said right here at the top that if x is less than 1, that would be an open circle with the arrow going to the left. Waiting. What's the question? No? All right. So, I got to plug a 1 into the next one. What is 1 minus 2 quantity squared? 1 minus 2 quantity squared. All you're doing is going through the parabola and plug it in. What do you got? Okay, it's not that hard to square -1. I'm sure you're more than capable. You get a 1, don't you? And then what happens if you plug in a 2? What happens if you plug in a 3? What happens if you plug in a 4? What happens if you plug in a 5? All of those points can be pulled straight off your calculator using the trace button if you are not comfortable plugging in numbers on your own. Okay, let's answer these questions. What's f of 0? We can either look at the function or we can look at the graph. We can look at the equations, and if you're going to plug 0 into one of them, which one would you plug it into? Would you plug it into the top or the bottom? Isn't it the top one? Isn't 0 smaller than 1? So you'd have to plug it into the top one, and you would get a value of 1. Now, since we have that cool picture over there, we can use the picture. What do you get when you plug in a 1? Where would you be putting that in this equation? Probably the second equation, right? Because 1 fits in that category. And you also get a 1. What happens when you plug in a 2? I don't think so. If you look at the graph, you'll see that it's 0, right? Because it's on the, it's at the bottom of the little parabola, right? But look at the picture. It's giving you an x value, asking you for the y value that goes with it. Okay, make sure you get the delta math done.